Hi, today we'll be talking about deblurring and coloring images with deep learning. So our goal is to take grayscale blurry images as input, deblur and colorize them through deep neural networks, and restore them as sharp, colorful images. And the main novelty in our work is that it combines colorization and deblurring implementations that have been tackled separately before, and exploring how these two applications could merge the best. And so our dataset includes 1,050 images taken from Kaggle, separated into sets of slightly blurred, motion blurred, and sharp images that we post-process to grayscale. And we first experimented with two different colorization models, which were both convolutional neural networks, and one of them even used a pre-trained object classifier to help improve the colorization. However, we weren't able to achieve good results with either of these methods, since our results were colored in red-green or purple-blue scale. And an important reason for that is that for training an image colorization model, a much bigger dataset is required. And so we decided to use a pre-trained image colorization model instead and focus on the deblurring model of our pipeline. So for deblurring, we used a conditional GAN model working with two loss functions, which are the Wasserstein loss and the perceptual loss. And the final loss value was taken to be a weighted average of the two. So the GAN architecture consists of convolutional layers with half strides, as well as 9 residual blocks and convolutional blocks that are transposed, whereas the rest block layers are formed by convolutional layers and a normalization layer, where ReLU activation is used in each layer. As for the image colorization CNN model, every convolutional layer is formed from 2 to 3 convolutional layers that also include ReLU activation, and a layer for batch norm. And multinomial cross-entropy function was preferred as the main cost function for this model. So before training the deblurring model, we first experimented with the organization of the pipeline. And so we compared the two models to see whether deblurring should be performed prior to or after colorization. And we found out that when deblurring is performed first, colorization implementation actually produces a much more realistic color scale. We also tested the effect of multiple passes into the deblurring model on a heavily blurred image, like one that is not fully blurred after passing through the deblurring model once. But the results indicate that multiple passes into the deblurring model do not improve the resultant image, and as such we ended up using a single pass. We then trained the GAN model with motion blurred grayscaled images. For our main accuracy metric, we used peak to signal noise ratio, and we were able to increase the PSNR value of the final generated images from 28.3 to 29 with a batch size of 2, with a value of 30 and above being an indicator for a good quality image. And our next steps would be to train the model from scratch using a larger dataset and with different types and levels of blurry images in order to achieve a more significant improvement in the deblurring performance. Thank you.